In this section, we are going to talk about operators. So I wanted to just give you a quick overview, a couple terms, and I tell you what operators are, and then we are going to dive into a lot of examples of the different operators. So operators use different functions that use a symbolic name, and they perform all sorts of different actions in the program itself. The most common types of thing you do is you perform mathematical or logical functions. So you do arithmetic type stuff, 5 plus 9, 3 plus 8, or you compare things like, is this number or variable greater than this variable? And instead of actually calling a specific routine like a printf or a scanf, you don't call a function. You just see a symbol. You just use like a character, these symbols, less than symbol, or the plus symbol. These are called operators. So operators are predefined in C. Just like other languages have this concept of operators, and most operators tend to be combined with the infix style. And all that means is that the operators in between the data. So I mentioned that operator can perform mathematical functions. Just 5 plus 8. Plus is in the middle between 5 and 8. And that's referred to as infix style. You can actually do like plus 5 8, that's considered prefix style. And then postfix style would be operator is after the arguments. So 5 8 plus, for example, but we are most familiar with the how you do math in high school and everywhere else. So the actual operators goes in between the arguments, which is referred to as the operand. So operators and operands, you want to think of those two terms. Operator is the actual symbol, and operand are the arguments to the symbol, and that are usually on the left and right hand side. But again, it depends on the actual operator. So we are going to talk about logical operators. These are sometimes called the Boolean operator because they return true or false values. And we know what a Boolean is. Boolean variable at least. So it's an operator that returns a Boolean result, true or false, that based on a Boolean result of one or two other expressions. And so we have also been hearing this term expression a lot. So I wanted to formally define that as well. We'll do that in a second, and how it's a little bit different than a statement. Another example of an operator would be arithmetic operator. As I mentioned, plus, minus, to operands on the left and right hand side. You perform some calculation. Other operators include assignment, where you are assigning the data, and we are done this in previous challenges, in previous lectures, and this is the most common thing, that's the equals operators. And then there's thing like relational operators, which are really comparison operators, less than, not equal, that's used with the exclamation point. And then bitwise operator, where you can perform operators on bits, and we will talk about that as well. So this is just designed to give you a little introduction to what an operator is and how it can be very useful. Now, in order to really use operator, you have to understand a couple different terms. I have been using these terms kind of casually, expressions and statement, but I have not formally defined them. And it's important to know the difference, because if you read or learn about anything in programming, you are going to hear these two terms, and you may have been brushing them off, and you understand what they are, but you should know there are specific differences. Usually you can identify the differences. For the most part, statement and semicolons, expression don't, and expression written values statement don't necessarily. But let's go through a formal definition. Statements are the basic programming steps of C. Most statements are constructed from expression. So you see a combination. You may see an expression inside of a statement. I will give an example of that. So an expression consists of a combination of operators and operand. And now that we know what an operator is formally, and we know what an operand is. Operand is just the arguments to the operator together. That makes an expression. We can now actually say what an expression is. Operands are what an operator operates on. I mentioned you that they are arguments. Operands can be constant variables or a combination of the two, or it can be 5 plus 8, it can be variable x plus y, or it can be variable x plus 8. Every expression has a value, and expression returns generally. Examples of expression: negative 6 minus. Minus is an actual operator in C. It's a unary operator, single operator with a single argument. And then 4 plus 21, where the operator is plus, and it's a between two constant. This is an expression. And then another expression, it's a little more complicated. Many operators, the star for multiplication, the plus for addition, and the forward slash for division. And then you see an assignment, which is equals 5 times 2. That's where you have an expression 5 times 2 on the right hand side. You have a variable on the left hand side. Together, those make up a statement. Another one is x equals plus 2% 3. We'll talk about those plus as an incrementation operator. Percent is a modulus operator for remainder, and then a comparison operator q is greater than 3. A variable q is greater than 3. But these are examples of expression. Now, statements, we have mentioned that they are the building blocks of a program. But there's different types of statement. We have already learned how to declare variables. That actually a statement, that's a declaration statement. So a program is going to use a series of statements with a special syntax ending with semicolon. Those are referred to as simple statement. Statement that are single lines that end with a semicolon. You can also have compound statement, which I will tell you in a second. But a statement is essentially instruction to the computer. So declaration statement, data type followed by variable name and then a semicolon. That's an example. An assignment statement, JSON equals 5. It uses the assignment operator. It's not an expression. It's just JSON equals 5. A function call statement, when you call a function printf, that's the one function we know. And we call that JSON, pass it. A structure statement, we have not learned this syntax yet or this keyword, but this is a loop where it has a single statement on a single line ending with a semicolon. A return statement is when we return data from a function. Again, we don't fully understand what this means, but you see, it ends in a semicolon. These are different types of statements. So C considered any expression to be a statement if you open a semicolon. So that's why some of this looks a little tricky when you see JSON equals 5. You might have thought initially that's an expression because it has the assignment operator, but because it has a semicolon, it's actually referred to as a statement. Again, not necessarily super important to yourself that expression, why they keep saying expression. So expression statements that end in semicolon or statement themselves or referred to as an expression statements. So in C, it's that perfectly legal to just have a number and a semicolon. Even though it does not do anything and is wasteful, but it is okay and same as 3 minus 4 semicolon. That's an expression normally, but it ends in a semicolon. So it's an expression statement, but you are not doing anything with it. You are not assigning it, but it is perfectly valid. But no reason to do these two examples. Compound statements are a little different than a single statement, where you just have a semicolon at the end. And I tried to tell you what a block of code is previously where you have the brackets, but this is where you just have multiple statements and then they group them together, basically braces. And that's referred to as a block. So an example, what would be something like this int index equals 0, that single statement and with a semicolon. Well, while index is less than 0, this is while loop. You don't have to understand what that means, but what you should notice here is this braces. A starting braces is on the left and left braces to start and ending braces is on the right or at the end, which is a right braces. It looks like the main function where the main routine has a left and right braces, and I mentioned that's a block of code. So a block of code is just multiple statement, but that's referred to as a compound statement as well. And we'll talking about blocks and how you can use these braces for while statement looping. And if in this lecture we are going to discuss some of the basic operator supported by the programming language, C programming language. So operator, again, just special symbols for function. You are performing some kind of operation. So we are going to discuss basically in this lecture 4 different types of operator: the arithmetic, logical, assignment, and relational operators. And then we are going to discuss in another lecture the bitwise operator. And then a couple other special operators that don't really look like they be an operator, but they are the size of operator and the casting operator. So an arithmetic operator is probably the most common sense one. that one that you are probably most familiar with. It's a mathematical function, takes two operands and perform calculation on them. It's a infix, so the operators and between the operands. A logical operator, sometimes called a Boolean operator, is an operator that returns a Boolean result, true or false value. That's what an Boolean is. So it's really just a conditional operator. It's based on the Boolean result of one or more, two or other expression, one or two other expression. An assignment operator just sets variables equals to values. It assigns the value of the expression at its right to the variable at its left. So it's a right operand and a left operand. Again, it is infix, and then a relational operator will compare variables against each other. So this is a kind of comparable type order, less than and greater than. But let's go over each one of them, because there's many of the different operators. C supports a super rich set of operators. So the first ones are these arithmetic operators in C. These are the mathematical functions. So there's a little table that I found online from tutorials point website, which is nice. And this summarizes all the arithmetic operators in C that are supported. So the basic ones, just like in math, there's nothing really new here. On the left-hand side of the table is the operator, and the middle is a description of what it does. And then on the right is an example, so the plus symbol. So that's going to add to operand. It's an infix. It's in between the two operands. So what you would do is you could either add variables, you could add a combination of constants in a variable or just constant. And this one we are saying a plus b equals 30. But the actual operator and operands are just a plus b. And then what would be the example? Minus subtract two operands, a minus b. So a minus b could actually be equal to something like a negative 10. If a is equal to 20 and b is equal to 10, or b is equal to a negative 10. Asterisk is for multiplication. Again, infix in between operands. Division is the forward slash. Percent is modulus operator. This is the remainder operator. So if you were to say like a variable percent a, what is that going to be equal? If b was equal to 20, a was equal to 12. The modulus operator would return 8, because that's the remainder of 20 divided by 12. Plus and minus, these are the specific incrementation and decrementation operator. They are still referred to as an arithmetic operator, but you typically only see them mostly in loops when you repeat code, but not always. I mean, in this example here, basically you are incrementing a variable by 1 or by a specific value if you're doing something else. But so if you do a plus plus, whatever a was, if it was 5, it's going to be equal to 6. And then there is a decrement operator which decreases the integer value by 1. So a minus minus, and the plus plus and minus minus you should notice are after the variable. This referred to as a postfix. And what this means is, if that variables in an expression, it's actually not going to be assigned the extra one until after that statement. If it's a prefix, it will be assigned before. So let's go through some examples of these arithmetic operating code blocks so that they make a little more sense. So here are the code blocks. Here's our main routine. We are familiar with this by now. I'm just going to create a couple variables and do some operations on them, and then print them out. And I'm just going to create integers. It doesn't matter though you could create floats to do calculation or doubles, but we will just make it basic. We will say a is equal to 33. Create another variable of type integer, and we are going to assign that to 15. So we are doing a declaration and an assignment in a single statement. And then we are just going to have a result variable, and this is going to be a initialized to 0. So here we can start performing calculation. We can say C, and we can do assignment. We have not learned about assignments specifically formally, but we know what assignments are. Assignments are taking data and putting that data in that variable. So C equals is taking whatever is on the right hand side and putting the result into that variable. So if we say a plus b, again, this just looks like normal mathematical routine, and it would just be 33 plus 15. And what would be the value of c? 48. And so you could just print out the value. You could just say c is present percent t using our format specifier and just printing out c. And then maybe we could do a line feed, and that would just add two numbers. It's that basic, it's that simple. We are just displaying it. So when we run this program, we are going to see the addition of 33 plus 15. We recompile this, save it, say build, and then say run. You will see that when I run it after my virus scanner, it says C is 48. So you can play around with these. I mean, these are basic. So a plus b, you can do the minus, you can do the asterisk for multiplication, then you can do the division for forward slash, and then the percent symbol, which is modulus. So this is interesting because 33 divided by 15 would be 2 with a remainder of 3. So result is going to be 3 in this case. Let's just make us sure though, save this and make sure we close our execution. And when we run it, we can see that we have c is equal to 3 because that's the remainder. Otherwise, it's pretty basic. The important ones with the plus plus are to understand the prefix and the postfix. So if I were to say, and this is more relevant when you actually do it in a single statement printf. So let's say I print out a plus plus. What that's going to print out is 34, 33 plus 1. Because you are going to increment a by 1 and then print it out. But you are going to do it in a single statement. You are going to do in the same line because it's afterwards. So actually what's going to be displayed here, it's only going to display 33. It's not going to actually increment until the next line of code. So if we run this, you will see it just print out 33. Now, that's the difference between doing a plus plus a. If you do a plus plus a, which is the same thing, you are going to increment by 1. Difference here though is you are going to increment by 1. And then before the statement is executed, so here now we'll notice that we just have a couple warnings, no errors. And when we run it, now you will see the answer is 34 because it's actually incremented before the statements is executed. And that's important to know between plus plus variable name versus variable name plus plus. That's just referred to as prefix or postfix. The same would happen for the minus minus. So keep those in mind for you. Unary. These are also unary operators because they only have one operand. The other ones are binary operators because they have an operand in between the operands, two operands. But understand the minus minus versus the plus plus. And then also understand if you place it before the variable, after the variable, when it's going to actually increment or decrement. Again, all it is, if it is after the variable, it's increment or decrement, right? Then because it execute the line of code. If it is before the variable, it's going to execute the line of code. And then after that executed the statement, it's then going to either increment or decrement. But play around with this. Open up a window. Do a bunch of different arithmetic expression and see how it all works. Now let's talk about some of the other types of operators The next group of operators are referred to as logical operator, and we define what this means is it basically is conditional type operator. They return Boolean results, true or false values. So the symbols that are represented logical operator are the ampersand symbol, ampersand. The two parallel bars and the exclamation point, the ampersand is called the logical and operator. It's also an infix operator that takes two operands, one on the left and one on the side. Basically, if each operand is a non-zero, then the condition becomes true. And so non-zero means 1, which means true. So if A is true or B is true, then the answer would be true. If A is false, B is true, answer is false. If A is false, B is false, answer is false. So again, we will do some examples of that. And then parallel bars are the logical operator. And again, this should be similar to your math class. So I don't want to spend too much. These two operands is non-zero, other one is true. Then it's true. So if a true is and B is false, it's true. And this are expression that return values. So the return would be if A is true and B is false, its return will be true. And then the logical not operator, which is the exclamation point, this just reverse the logical state of its operand. So if the condition is true, then it's going to return false. So if you say not A, the exclamation point and A was true, A is false. If you put the not outside of parenthesis, whatever A and B evaluated to, it's now going to value to the opposite. So let's again look at some examples and code blocks. Here's code blocks. Again, I'm going to create a couple variables to demonstrate logical operator. Again, I will just create some integer. We'll say I equal 12 and then b equals 20. And what would be better is we'll create because I don't want to utilize condition. So we'll just create an underscore boolean and we'll assign that. I will say that will be results and we will initially not assign that do anything and then we are going to just print out some data. So we want to see what the values are these expressions returned if we use the logical operator. So in here, I'm going to print out %d, which is an integer. Because remember, Boolean expressions are just integers. Boolean variables are integers. So if the Boolean value is 1, then that means it's true. If it's 0, it's false. Anything else is usually 1, it's true. So I'm just going to print out the result. And then I am going to assign some data to it. So if I say results equals A and B, now that's not going to make any sense because these are numbers. So let's initialize A equals to true and again use booleans. And here we'll say this is true and this is true, and then we use the ampersands. This is saying A and B. Both have to be true in order for the return to be true. So results should print out 1 because 1 represents true. So it's build this and make sure that we have to use the right namespace. So we are just going to represent 1 for true and 1 because we would not doing the right include. So that's no big deal. So now we run, it should report true 1 and it does 1. Now, if I change any of these to not true, if I say 0, then the result is going to be false because A and B both have to be true in order for the results to be true. So if I build this and I run it, you are going to see that the result is 0 because it's false. So either one, if I change A or B to 0, which means false, the result would be false because both A and B have to be true. Now, if I say a parallel which is A or B, only one of them has to be true in order for results to be true. So in this case, results should be 1. So let's build this and run it. And now we have a value of 1. So only one of them has to be true. So now, if I make them both false, then this is going to be much more applicable when we talk about if statement and conditional and making decisions. But I am demonstrating Boolean logic here. Now, both are false. So this should return 0, which is false. And it does 0. So pretty neat. And then the last one is just the not symbol, which is the exclamation point, which just does the inverse. So if I say not A, if A is equal to 0, A is now going to be equal to 1, or result will be, and result is going to be equal to 1, which it is. So those are the 3 logical operators. Again, they will be used in usually decision statement. So let's now move on and talk about another set of operators. Now here are assignment operators. We are pretty familiar with at least a simple assignment operator, which is equal symbol. The equal symbol assigns data, and that's pretty basic. C equals A plus B. C is going to be the result of A plus B. Now there's these compound type of operator where you can do plus equals or minus equals or star equals. Plus equals is where you add, and the assignment operator, so it adds the right operand to the left operand, and then assign the results to be left operand. So you could say C plus equals A, and that's the same as saying C equals C plus A. Minus equals the exact same thing, except you are subtracting. You are subtracting and then you are assigning. So you subtract the right operand from the left operand and then assign the data. So if you say C minus equals A, it's really C equals C minus A. It's a shorthand notation. These plus equals and minus equals, you can write things a little faster because you do 2 operations essentially in one single statement. And then multiply the same thing. Star equals multiply and assign. So C star equals is A is equivalent to C equals C times A. That's pretty straightforward. I think the other assignment operator are similar, except you are using division. So division equals is divide the then sign, percent is do the modulus, and then assign the result. So those are pretty straightforward. And then we have some other ones which we are going to talk about in another lecture in more detail. So I'm not going to touch them on here because they are really completely different. They are called the bitwise operator, which is left, and all I'm saying here is that for those bitwise operators that we are going to talk about, you can also assign them in single statement. So shifting, doing a left shift and right shift and assigning, you can just do less than equals and write greater than any greater than equals, and then again the ampersand, the caret, and the parallel bar are all related to doing things on which. So we'll come back to that, but they are part of the assignment operator. So the assignment operator is just pretty easy, assigning data, and then if you want to actually do expressions, a couple expression, then assign it. You do the combination ones. The relational operators are comparison operators. They compare two values. So this is important equals, we'll compare the value of two variables, and if they are the same, it's going to return true, because it's going to return a boolean expression, true or false, or boolean value. Exclamation point equals is checking if the values two operand are equal or not. So A is not equal to B is how you want to read that. If A is true and B is true, and that's going to return false because they are equal. So A would have to be false or B would have to be true or vice versa. And that would return true. The greater than symbol is checking whether or not A is greater than B. Less than symbol, A is less than B, greater than equals. A is greater than or equal and less than equal. So again, this is all basic math stuff. I'm not going to go through examples in the IDE because this is pretty straightforward. Comparison operator is just like a math greater than equals and so forth. So hopefully we have a good handle on the basic operator, arithmetic, logic, assignment, relational, use a quite bit. So you need to understand them. Hopefully it's not too difficult or confusing. You are going to use a lot of this in if statements and decision statements. We have showed you a little glimpse of this in the previous lecture when we talked about assignment operator, because assignment operator have all these compound assignment where you can perform an operation like an addition and then also assign. You can do the same thing with these type operators, but let's got into these more detail and exactly tell you what they are. So C offers bitwise logical operator and shift operator. Those terms might be completely clueless. They look like logical operators, but they are quite different. They don't do any kind of Boolean evaluation. They don't evaluate true or false. They look like the ampersand, the two or, but they are not doing any kind of Boolean evaluation. What they are doing is they are operating on bits inside integers values. And so you may ask yourself, why the heck would you ever want to do this? Well, it's not used in most programs. It's more of an advanced technique. Even though this is a beginner class, they are part of the operators, and operators are a beginner concept. So I'm going to address them, but we are going to not necessarily focus on them. I will give you some examples, show you how you can use them. But you are not doing to be an expert in this after this lecture. But the way that they are useful and why you would actually want to use them is because you can store quite a bit of data. So there is a bitwise operands called an ampersand and a bitwise, or which is an or just a single parallel bar. Sorry. Try not to get this confused again with the logical operator. Logical operator have two of them, ampersand, which is an and symbol. The bitwise operator just have a single, so just an ampersand or just an so what they are going to do is they are going to test, and they are going to test individual bits inside of an integer variable. What is a bit? We know a bit is a way to measure data, but a bit is essentially just 0 or 1 value, and 8 of those make up a byte. So a bit is 0 or 1. And what you can do is an integer. Remember, depending on the system you are running, could it be 8 bytes, and you could turn on and off each bit. And when I say turn on or off, I'm saying you can either have them be equal to 1 or 0, and then you can use those bits to tell you something. So you can store a lot of data by having bits represent some kind of data. That's why one of the reasons why the computer uses bits in 1 or 0 and binary numbers to do operation, because you can store a lot of data. Now, exactly what this means is, here's an example. You could use a single integer value. Again, an integer is a number. An integer represents 4 to 8 bytes, depending on what system you are running. That means if there is a 4 bytes, that means there is a 32-bit system, 32 zeros or ones values. So you can use all those bits to represent something. So for example, if you want to store individual characters, a person, you could just have one bit tell you whether or not the person is male or female by saying 1 is equal to 0, 0 is equal to 1 is equal to male, or 0 is equal to female. You just either turn it on or turn it off. Then you could use 3 bits to specify whether the person can speak French, German, or Italian. So the 1 bit could represent French. If it's not 1 0, then that means they don't speak French. If German is 0, that means they don't speak German. If it's 1, it means do speak German. So By turning off and on these bits, setting them to 1 or to 0, you can represent a lot of data. You could have another bit to record whether the person's salary is 50,000 or more. If it is 1, it's true. If it is 0, false. So basically, we just specified here. It actually say 4, but we actually specified 5 bits of data. Only 5 out of whether or not we have 32. Or if we have 64 bit, but we only use 5 and we able to represent whether or not a person is female or male, whether or not they speak French, German, or Italian, or all three, one of the other, and whether or not they are making more than 50,000. We can represent all that data in our bits. And this is where the bitwise operator come in handy. Now that we know how we can use bits to store a lot of different data, let's talk about those binary numbers. We know that a binary number is just a number that represents, that includes 1 and zeros, and that's why it is advantageous to use bit operator in an integer. The number can be of any length. The following are examples of binary numbers, just zeros and ones. So you have seen this 0, 1, 0, 1, 0, 1, 1, 0, 1, 0, 1, 0. And remember that a byte is 8 bits. An integer is usually 4 bytes on most platforms. It depends on the architecture, but mostly 32 bits. So you have 32 values that you can store with ones and zeros to indicate on or off. Binary number, again, every binary number has a corresponding decimal value. So you need to understand how to convert binary to decimal. Example here, 1 is equal to 1, 1 0 is equal to 2, 1 1 is equal to 3. These are simple conversions. Again, usually they have more bits, 1 0, 1 0, 1 1 1. The way that you want to convert the binary numbers to a decimal number is you want to look each position in the white with the bit corresponding bit, and you then use the power of 2. So for each digit, you multiply the digit by its position value using the power of 2, and then you add up the entire project to get the final result. So position values and binary numbers are the powers of 2. So the first position would be the value 2 0, which is in other words would be 1. And then the second position would be the value of 2 to the power 1, which is 2. Then 2 to the power 2 would be 4, 2 to the power 3 would be 8, 2 to the power 4 would be 16. And you keep doing that over and over again. And so it's easier to understand if you see a nice example. And so here we have a binary number of 0, 1, 1, 0, 1, 0, 0, 1. The decimal equivalent of that is 105. The way you convert is you start on the right hand side for each bit, and you multiply to the power of 2 depending on if the bit is 0, 1. So if we start all the way to the right, we have 1. So we say 1 times 1 and we keep that 1. Then the next one, the second position is 0 times 2, 0. Then 0 times 4, 1 times 8, 0 times 16, 1 times 32, 1 times 64, 0 times 28, 128. And you add all those up and you get the result of 105. That's one way to convert. You can actually convert it left to right as well by multiplying 2 and then adding 1 or adding 0 depending on what the next bit is. So for example, you can also, if you go left to right, you start off with 1 because 0 doesn't matter. So the second bit going from the left to right, you have 1. The third bit, you have 1 times 2 plus 1. So you have 3. And again, you multiply by 2. So you have 3 times 2 plus 0, which is 6. 6 times 2 plus 1, which is 13. 13 times 2 is 26. And 26 times 2 is 52. So then 52 times 2, which is 104 plus 1. So again, multiply by 2 and then add 1. Another example. Again, the right to left is usually a little bit easier. Here is 1, 0, 0, 1, 1, 1, 0, 0. Another example, and that converts to 156 because you say, again, 0 times 1, 0 times 2, 1 times 4, 1 times 8, 1 times 16, and so forth. And then you add up all them together, which is 4, 8, 12, 16, 28 plus 128 is 156. And again, if you go left to right, you multiply by 2. Add 1. So we start by 1. Say 1, 2, 4, 9. 4 times 2 plus 1, 9. 9 times 2, 18. Plus 1 is 19. 19 into 2, 32. Plus 1 is 39. 39 times 2, which is 78. Times 2 is 156. So this is a quick demonstration of how you can convert binary to decimal. Now converting decimal into binary, I usually just use a conversion on the web. If you are really interested in that, but you can take these binary numbers and then perform bitwise operator. So let's take a look at the bitwise operator. So the bitwise operator are summarized here. And again, another nice table I got online, but they look similar to the logical operator. But again, don't confuse with logical operators. So the ampersand by itself is a binary and operator. And so what this is doing is it's copying a bit to the result if it exists in both operand. So if both of them are true, then it's going to copy a bit. So if A and B is equal to 12, we are going to have a binary representation of 0, 0, 0, 0, 1, 1, 0, 0. So A and B would be that number. We'll go through some examples. A binary or copies a bit of it exist in either operand. So A or B will copy a bit if it exists in either operand. So if either operand is equal to 1, it will copy a bit. And then the binary XOR. This is the exclusive OR. This will copy the bit or if it is set to one operand but not both. So if you have a true but only one true and you use a caret to represent this on your keyboard, then it's going to copy a bit and it's going to say it's true. Binary ones complement. So again, we are getting the binary data here. So because we are talking about bits, so hopefully ones complement operator is unary and has the effect of flipping the bits. Basically just negative and negating and taking the monitor off. How it would be represented. So I will go through more concrete examples of this, but basically if you have a binary number, A is initially a binary number that's 0, 0, 1, 1, 1, 1, 1, 0, 0, which is 60, and you supply the flipping. Basically, it's going to then turn into negative 61, which is 1, 1, 0, 0, 0, 0, 0, 0, 0, 0, 0, 1, 1. So this is the results of variables that are actually set. So again, I am assuming that A has certain binary representation, B has certain binary representation. So if A is equal to again 60 and B is equal to 13, then the result of adding them together doing a bitwise and is going to be 0, 0, 0, 0, 1, 1, 0, 0, which is 12. Again, I will go through these examples, but this is trying to provide a little description of these different binary operators. The less then symbol is going to shift bits to the left. So the left operand value is moved left by the number of bits specified by the right operand. So if you do something like less than 2 and a is basic actually equal to some binary number, for example 0, 0, 1, 1, 1, 1, 0, 0, you are going to shift the bytes by 2. So you are going to take off the zeros and it's going to become 1, 1, 1, 1. And those zeros are opposed to the left. Here you use the greater than symbol. So I'm going to go through these in a second. The other important thing to understand with the bitwise operator is how to evaluate these A and B values. So what does 1 and A1 evaluate to 1? If it is an ampersand, if it is an or 1 and 1 evaluate to 1 as well. But a 1 and 1 and a 0, if you are using an ampersand doing an AND, that evaluate to 0 false. So I just wanted to provide a little truth table here that shows you the values when you are doing it. You use an AND and an exclusive also here. If you have P naught, Q naught, which means they are both false. P0. Q0, and you apply, and it's going to be false because they both have to be true, that to be true. And that's what you see in row 3. They are both true, then P and Q is going to value to 1. True. If they are not both true, it's always false. P or Q, only one of them needs to be true. So that's why you see rows 1 and rows 2 equal to 1 and the row 3 equal to 1. The only time it's false is when they are both false. And then the exclusive or is at least one of them is true, and only then it is true. If P is false, Q is true, it will true. If P is true, Q is false, it will return 1. So this gives you an idea of how it's evaluated. Again, a lot of math stuff, but when we talk about binary digits, that's what we are talking about. So let's look at some concrete examples and code blocks. Hopefully this will help a bit. So here is our function. I'm going to create a couple more variables. I'm going to make sure that they are unsigned, even though that's by default. So if I say unsigned int a and assign it to 60, that's actually going to be represented in binary as 0011 and then 1100. If I create another unsigned variable and I say int b and I assign that the value of 13, that's going to actually represent as in binary 00001101. You can do the conversions there. But what I want to demonstrate here is that when you set these binary numbers up, you can turn off the bits by using the different bitwise operand. So now, then I'm going to just create a int result, and I'm going to say that's going to be equal to 0. E is going to hold the results of the bitwise operation. Now, if I say C equals A and I apply the bitwise operand and A and B, now what that should do is, if A is equal to 1 and B is equal to 1, that bit's going to be turned on. So what would you expect the result of this be? Well, you look at the first bit of A and you look at the first bit of B, and they are both 0. So the result is going to be 0 because if you do it true in A and B, they both have to be true in order to be 1. So the next one is also going to be 0, the next one is 1 and 0, third bit. So it's still 0, 1 and 0 is still, then now we have a 1 and 1. So now we finally have a true. We have another 1 and 1, we have a 2 and 0 and 0 which is going to 0 and then 0 and 1 which is going to 0. The result, if I want to try to print out C, it's going to print out the value in decimal format. If I were to do something like that, it's going to print out the decimal equivalent of that binary number, which would be the equivalent of 0000. And this is all converting binary to decimal. So you need to understand how to do that to understand this example. But 00001100 is actually 137. The result is actually is 12, 13, 6, 12. So this would print out 12. If I were to print out C, or result would be better. So if I run this, you are going to see that the value is 12. It actually turned it off and all the bits based on the ampersand comparison. So now I say run, we see that the value is in 12 because it's turning off and on the bits, and it's going to actually be represented as 00001100, which is the value 12 because we are printing out a decimal. If I were to change this and I want to now do an or, and I'm still doing the or, and or remember is the parallel bar right next to the enter. Now I am only going to turn on bits if either one is true. So 00, both of those are false. Again, I am comparing up here. I'm comparing these bits for 16 and 13. 16 is represented as binary 00111100. 13 is represented in binary 00001110. Each one of those numbers represents a bit. So the first bit in 60 is 0 and the first bit in 13130. And if I order those together, 0 and 0, I'm still going to get 0. So that's the first result of the first bit. Second bit 0 0 again. Third bit is 1460 and it's 0413. Now all that means I have to have one true, so that's going to be 1. Same goes for bit number 4 and 16. 13. So now I have a 1 again. And a 1 1, they are both true. So again 1, and all I need is one true, another one. Both false. So that's not going to be true. 0. Remember, is not true. 1 is true and 0 1 1. Now I have 0 0 1 1 1 1 0 1. And the value of that in decimal, if I were to print it out again, you have to understand how to convert a binary to decimal, but it basically goes 1, 3, 7, 15, 30, 61. So this is going to print out 61. And this program rebuilt it, we are going to see a value of 61. So that's bitwise operator, and again, it's a more kind of advanced programs, but it's nice way to represent a lot of data by using ampersand and so forth. By turning on and turning off bits essentially, so you could play around with this. You could do the exclusive or, which is the caret. The caret is of the 6 and 6 on the keyboard. You would see a different result. If you would add the tilde, that's just going to basically turn everything off. So if for a and a is equal to 60, it's not going to be now going to be equal to 11000011. Another real cool thing you can do with the binary operator is shifting left and right. There's a couple key things you know when you need to shift left or right. First of all, we know that an unsigned int means that can only be positive. It can't be negative. So if you are storing a negative value in there, the compile will convert it will be longer. It will take up a lot of size. So remember, unsigned ints mean that you can only have positive value. Signed integer mean that they can be negative or positive. But if you want to shift, remember, in order to shift to the left, so now if we say result equals, and let's say we want to shift, let's say by 2, other important thing you want to know is when you have the integers are, remember, they are 4 bytes most platform. It depends, you can get the size by doing the size of operator. So integer is really 4 byte size, is 32 bits. So really the number is something like the 60, something like that. That is 4, 8, 12, 16, 20, 24. So you probably something like that and do something like that. That's really the number. I only showed the last 8 bits because the rest were zeros. But if you look at this as a 32-bit integer, which is 4 bytes, this is what it looks like in binary. 4 zeros, 4 zeros, 4 zeros, 4 zeros, 4 zeros, 4 zeros, and then the 0 0 1 1 1 1 0 0. And so you got to know the size when you do the shifting left or right, because if you shift more than 2, it's not going to be clear. So again, it doesn't drop off or anything like that. So again, let me just make sure 48, 12, 16, 20, 24, 28, 32, and the same would go for 13. So if you want to shift to the left, a greater than 2, that's you are end up going to have is these ones are going to shift to the left 2. So the result is going to be still all those preceding 0. But then you are going to have 1 1 1 1 0 0 0 0, and that is going to be equal to 240, 240. And if I do a quick conversion, I do it in my head by saying 137 15 30 60 122 40. But we can confirm that by building and running, and you will see that the result is 240. And we see the result is 240. So now if you want to actually shift to my more than 2s, say you want to shift by 4, this is when it becomes important to understand that it's a 32-bit number. So here you would actually have to use some of those zeros. So if you want to shift by 4, really what you would have is you would just have something like that. And then if you want to group them by 4, you would have something like that. So the result here would be again if I do this in my head, you have 13, 7, 15, 30, 60, 120, 240, 480, 960. Hopefully, I did that right. Again, when we run this and we say 960, so that's shifting to the left. If you want to shift to the right, you use the greater than symbol. So shifting to the right, binary right shift operator, you do the greater than, binary left shift operator, you do the less than. So here, if you are going to shift to the right, you want to move to the right 4. And what happen if you were the have the end here? So if you have your original 60, you try to go 4. You are going to have digits that just get dropped off. Instead of having these last 4, which originally again we have 60, so we have 0, 0, 0, 1, 1, 1, 1, 0, 0. We have to move over 4. So we are going to end up losing 2 bits because they are just going to drop off. And what we are going to end up with is something like this 0, 0. And so this would just be equal to 3. Something like that. So you actually lost bits because you are shifting to the right too much. You have the result of 3. So you have to be careful when you shift left and right. Make sure you use those 32 bits for shifting. Four bytes, again, depending on your system. It's a quick summary of bitwise operator. When you get more advanced, you have to understand how you can actually check if a particular bit is 1 or 0. It's pretty simple. You just do an on it, but you do have to write a little bit more code. This lecture was not intended to be an exhaustive look at bitwise operator. I want to give an overview, give you a good head start on it. But in order to understand these operators more, you are going to have to study quite a bit more and use them and practice them on website like Geeks for Geeks. So I hope this was helpful. Again, it can get a little confusing, so you want to follow and you want to play. Hello and welcome. In this lecture, I want to talk about a couple operators that are little bit strange in the sense that you wouldn't necessarily think they are operator. Because all the operators we learned up to this point really just point to sort of using the symbol to do calculation of numbers. And these operators actually sort of look like operator. In order to first talk about the cast operator, I have to tell you a little bit about type conversion. So, how data is being converted, we learned all about data types and different data types out there. But if you are actually trying to assign data to different types, there's some implicit conversion that go on in the programming language. So, conversion of data between different types can happen automatically. And this is referred to as implicit conversion by the language or explicitly by the programmer or the programmer itself. The developer can do something. They can use a cast operator essentially to do a conversion. The data that's being converted implicitly is really important because you have to understand this because most C programs that you are going to develop, in order to effectively develop them, you have to understand these rules for these conversions because you are going to often have integers and floating point number, decimal numbers and whole numbers, and you are going to be using these, intermixing them kind of something. And when you do, you have to know how things are being converted. Now you should try to avoid that as well you can by using the cast operator. But when you don't use the cast operator, understand what's going on. What's going on here? When you assign data to different types, floats and doubles, the data is either going to be truncated or is going to be promoted. These are two terms that you are going to be here. Truncated means becomes less precise, and promoted means it becomes more precise. So try not to mix these types, but they may be useful. The main thing to understand is we know from earlier lectures that C is very flexible, and that's conscious decision by the designers of the language when they wanted to have it flexible, but again as a trade-off. As this additional freedom is given to you, you can abuse it. And so don't abuse this idea of mixing pages. Try to use the same types when you can integers with integers, floats with float. But when you can't either understand the implicit conversions or do the explicit conversion using the cast operator, so you again another issue or another concept where C is flexible, but you should not abuse it. So whenever a floating point value is assigned to an integer variable in C, so you have int x into y, x equals y, the decimal portion of the number is going to get truncated. So if you have a number int x equals 0, float f equals 12.125, and you assign f to x, the value of x is going to be 12. You are going to be lost that precision. The value is going to get truncated because you are assigning a float to an int. An int in only knows how to store a whole number. So it's automatically getting converted by the programming language, by the compiler to 12. Only the important thing is going to be stored. Now, if you assign an integer variable to a floating point variable, which is the opposite, it doesn't cause any change in the value of the number. The value is converted by the system and stored in the floating variable. So that you don't really have to worry about assigning it into a flow. If you assign 12 to a flow, it's still going to be 12, just 12.0. When you perform arithmetic or integers, and so this is different than just assigning values, assigning it into a float or float to int. This is when you have an expression. You are doing some addition, some subtraction, whatever the case may be. When you are doing a subtraction or an operand can be a float, you have to know how that what conversion is happening. So if you have two operand in an expression and they are both integers, then any decimal portion resulting from a division operation is discarded. So if you have an integer x, that's 20, you have an integer y, it's 12, and you do 20 divided by 12. You are not going to get 1 point something, something, something. You are just going to get 1. It's going to discard all the results and put it new because again an int only stores a whole number. So two numbers are ints and they are doing division. You are not going to get a floating point number. You are not going to get a decimal number. Now, if one operator is an int and other is a float, then the operation is going to be performed as a floating point operation. So if you have float f is 20, 20.0, float a is 10, and int, then if you do a division there or 12, I'm sorry, that's would be more applicable. Then the result is going to do a float point number and the result is going to be 1.888 or whatever it is 1 point. Whatever the case may be, you are not assigning this data to anything. This is an expression. What is it going to return? So two ints in a division, it's going to be whole number. An int and a double or a float, it's always going to be a float. It's always going to be a decimal floating point operation. And this is the implicit conversion. That's really what you need to understand. What's going on and done for you by the program if you don't do anything. However, you should try to do some explicit conversion, which is you can do with the cast operator. And this is just referred to as casting more or less. And you see casting in many languages when you want to convert, and all it is you are doing explicit conversion. You are saying that you want the data to be, you want to do this if you can, because otherwise data might get demoted. It might get lost. If you do two ints and you are doing division and they are not divided equally, you are doing to lose all that data. So it's possible for you to demand the precise type conversion that you want by explicitly specifying it. This is called a cast, and it consists of preceding the quantity with the name of the desired type in parentheses. So parenthesis and type name are constitute the cap operator. You do a left parenthesis and then you specify the data type in the right parenthesis, and that's going to convert whatever is to the right of it. Whatever the expression is to the right of it, or even if it's just a single variable, it's going to convert that to whatever inside the parenthesis. So the actual type is desired, such as long, it's substituted for that word type. So the type passed operator has a higher precedence than all arithmetic operator. Except the unity minus and unity plus, we have not learned about precedence yet. We are going to, in the next lecture, precedence is basically what happens, the order of the operation that are performed. So we'll provide some examples of that. All you have to understand at this point is that the typecast operator takes precedence over every other operator except two unary minus or unary plus. So here example, we have a number 21.51 and we have the cast operator because we know it's cast operator because it's parenthesis and it has a type. And what we are basically saying is take 21.51, convert it to an int. If you take a floating point number, convert it to it just becomes the int, the whole number 21. Same it's doing on the right hand side. It's converting 26.99 to an int. So what would actually happen here if you did this expression in a statement? It would evaluate as 21 plus 26. It would truncate the data from 0.51 to a whole number and the same as 0.99. And so that's the cast operator, anything inside parentheses that contains the data type. You will see this a lot. If you were to say 21 plus 26 and you cast it into float, it would just add a lot, 0. Usually you don't cast to a more precise type because you are not going to get more precise. You cast from more precise type to a less precise. So more of like a float to an int. You will see this throughout some programs occasionally when you are using different types. You should try to avoid using different types if you are doing arithmetic. But if you do, you will see this. The size of operator, another operator that's kind of strange, not similar to a lot of the other ones. And this is actually look like a function. But the size of an operator, it performs an action. It's not doing anything function oriented. What it's doing is it's telling you how many bytes are occupied in memory by a given type. So it look like a function because it takes an argument. And we are going to give an example of that, but it's just going to return the number of bytes in memory. Remember that depending on the system that you are running, the platform that you are running, the operating system, the architecture of the computer, the hardware, different data types are going to be represented memory with different sizes. For example, if int might be 4 bytes on one system, 8 in another, what you can do is you can use the size of operator as a special keyword and operator in C. And you can pass in a data type and it will tell you how many bytes it's using in memory. So size of operator is actually an operator. It's not a function. It's evaluated at compile time and not at running runtime, unless a variable length array is used in its argument. And so we will mention that this is basically saying that if you have a variable that inside the size of an array, it's not going to be resolved at compile time at runtime. So not that important to know. The argument to the size of operator can be a variable, an array name, the name of a basic data type, like int, float, the name of a derived data type, anything or an expression. So you would say size of x plus y, and that's basically just going to say the size of x plus the size of y or the resulting numbers. If x is an int, y is int, and its size of 16, it would say this is an int 4 bytes. If it was int 1 was a float and the result was floating point arithmetic and it will float is 8 bytes or something, but you can use it for many things and you should use it for many things. Size of int, for example, will result in the number of bytes occupied by the variable of type int. So this would return 4 or 8 depending on your system. You can also apply the size of operator to any expression as I mentioned. The result or the size of the value that result from the area expression. So if two ints together, they are still going to be an int. So it's still going to be a size, but you will see the size of operator also being used when we talk about pointers. I wanted to talk about this now because it's an operator, but we are going to provide many more examples of this and casting throughout the class as we talk about more concept. Specifically, when we talk about pointer, because when we are calculating how much memory to allocate, which is what pointers are you are use size of, because you want to be precise, but you can use it for other thing as well. So use a size of operator whenever possible to avoid having a calculating hard code size into your program. Hard code size magic numbers are not a good thing, because again, if you are on different system, if you were to hard code 4 on one system for an int, on the other system might be an 8, so use size of as much as you can, and you will see the this come into much more relativity when we talk about pointer. Other operator that are a little strange and the asterisk operator, you may have said to yourself, asterisk, we have already talked about this in multiplication, but that asterisk takes two operators, one on the left or one on the right. If you apply the asterisk operator to a variable and you just say star variable name with only one argument to the right, it represents something else. It actually represents a pointer. It's differencing a pointer. And again, this is, I am not going to hire on this now, because we are going to go through this when we talk about pointers. But if you see something like a star, don't freak out, that's actually valid. That's doing the asterisk, the pointer operator. You may also see the question mark colon. This is an operator that's used for decision making. If condition is true, if the thing to the left is true, and the result value to the right after the colon is evaluated, and so forth. Otherwise, it is short-form notation for an if-else statement. It is a ternary operator, it's called. But again, I don't want to really discuss these in a lot of detail now, because we are going to talk about these when we talk about our specific subjects. We'll talk about the ternary operator when we talk about decision statement. We'll talk about the strict operator unary when we talk about pointers. Hello and welcome. Now that we are talked about all the main operators, the fundamental ones, the weird ones, we have to talk about this little concept of operator precedence. So this comes into play basically when we how to do you evaluate the order of the operator. So operator precedence determine the grouping of the terms and expression and decide how an expression is evaluated. Now you really don't need to understand any of this. If you use parentheses, which we'll get to in a second, but you have to understand this concept because it's a part of the language, it's a part of understanding the language. So precedence is going to dedicate the order of the evaluation when two operators shared an operand, and this is going to become clear with an example. So for example, the multiplication operator has a higher precedence than the additional operator. Certain operators are going to have different order of evaluation. So if you were to do a compound statement where you are performing many different calculation, for example, 7 plus 3 times 2, this can have multiple results. The addition and you are doing the multiplication. You need to understand, do I need to do the addition first or should I do the multiplication first? Because depending on what you do first, change the result. So for example, this x equals 7 plus 3 times 2, the result can either be 13 or 20 depending on the order of when you evaluate each operand. So the order of the executing the various operations or can make a huge difference. This is why you need to understand precedence. C provides specific rules for choosing what to do first. In this case, do I do the multiplication or plus? Well, C is going to tell you what's going to happen. Ideally, if you wrap those in parentheses, you would be telling it what to do. You would be making that decision. But if you don't put that in parentheses, the programming language is going to make the decision for you. So in C, multiplication is going to have a higher precedence than the addition operator. So what's going to happen is the result is going to be 13. Now you could either say 7 plus 3, which is 10, and then multiply by 2. The result would be 20. Or you can do 7 plus 3 times 2, which is 7 plus 6, which is 13. So that's how you can have different values. That's ambiguous. Do you do the plus first or do you do multiplication first? Luckily, again, that's decided by the language. But you can see how there's two different results. 7 plus 3 times 2. or 7 plus 3 times 2. You see the pause here. Now C is going to do the latter, it's going to do the multiplication first because that has higher precedence. So it's going to do 3 times 2, which is 6, and then it's going to add to 7. So the result X is going to be 13 because the star extract has a higher precedence than the addition. And so there are rules for every single operator, which operator has precedence over the other. There is a precedence level, and multiplication and division have higher precedence than addition and subtraction. So that's they are performed first. For example, you can avoid all this precedence and having the language decide for you if you provide parentheses. Parentheses will always group the expression at the highest precedence. So if I say 7 plus 3 and I enclose that in parentheses, it always going to do the addition first. If I say 3 times 2 and I enclose that in parentheses, it's always going to do the multiplication and then add whatever outside of the parenthesis. So you should really just be using parentheses. Always use parentheses. Otherwise, the language is going to decide for you. You have to memorize all the precedence level, which is hard to do, as I am going to show you in the next table. There's a lot of different operators and you have to know precedence for all these different operators. So it can become very, very confusing. This is similar to you know either you let the language do an implicit conversion for you or do it with an explicit conversion with a cast operator. Same type of idea here, just use parentheses. So if we look at this table, which we look at a second, I guess, because I first want to talk about associativity. Associativity is related to precedence because what happens if two operators have the same precedence, then how do you figure out the order? Well, then you apply associativity. So whenever operators have the same precedence level, then you apply addition rules. So associativity is basically whether or not you start on the left hand side and go to the right or right to the left. So if you share an operand and they are both executed in the same order, you are going to execute them in the order of the statement based on the associativity rule. So for most operator, the order is from left to right. So let me show you an example. If you say 1 equals 2 is not equals 3, the equals and the not equals operator exclamation point equals have the same precedence. So in this case, we have an ambiguity, we have a problem. We don't know what to evaluate first. We don't know if we need to do 1 equals 2 or 2 is not equal 3. And it matters because you are doing a Boolean expression. This is Boolean expression here. So it's guys written to true or false. So what you would do here is then you would apply associativity. The associativity of both the equals and the not equal is left to right. You are going to first do 1 equals 2. That's going to be false. And then you are going to say false, which is not equal to 3, which it is not. So I equals 2 equals equal to, and then that's not equal to 3. So the result is going to be false. So the expression on the left is executed first and moves toward the right. So how you want to think of that is basically it's equal to these parentheses. First, you are going to evaluate 1 is equals 2. And then if that evaluates true or false, you are then going to say, is that equal to 3? And this is confusing because I does not have true or false values, but I actual equals number, that the comparison operator, that's not the assignment operator. And we are not using variables here. So it's even more confusing. But if you were to put these numbers in variables and would just be saying like if x equals y, so if x was 1 and y was 2, that would evaluate to false because they are both not equal. And then if 3 was another variable, z which is equal to 3, you will say that x equals y is false. Z is equal to 3, so false is not equal to 3. So it would be false. So so first equals to execute first result, again 0 false. So this is the result. 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 So this is the result Then 0 is not equal to 3 executes, resulting in the 1 true. So I said false initially, but obviously 0 is not equal to 3, which the whole thing would evaluate to false. The whole thing would evaluate to true. I'm sorry, because 0 is not equal to 3. So 0 not equal to 3, I was saying it's false because they are not equals. But that means that is actually evaluates to true. So pretty neat there. Now here's our table that says all the precedence and associativity rules, and it's very hard to memorize this. So again, what do you do? Use parentheses. But here is the table. The highest precedence level is at the top. So the postfix operator have the highest precedence level, and if you are using any of those in the same expression, then you read left to right. So the postfix operators, things like the parentheses are the highest precedence. So every time you include something in parentheses, that's going to take effect. But you have the brackets and then you have a postfix operator. We have not talked about a couple pointer extra, which is this dash greater than, but we do know. Now, what plus plus and minus minus, which are postfix, those have the highest precedence. Unary operators, things like this plus minus, the exclamation point for not, the tilde for the bitwise, the plus plus, the minus minus, and then the casting operator is referred to as a unary operator because it only has one operand. And then the asterisk operator is the pointer operator, the ampersand is the bitwise, and the size of those have the next highest precedence. But here you are actually reading right to left to evaluation if you have two on the same line statement. And then again, we just go in orders. You have to know this order and memorize it. So pretty tough to do, but I did want to show it to you. Did just want to have a little illustration to show some of the tables. There's a lot of operator, and so there's a lot of precedence levels, and there is the associativity for the most part. Like we said earlier, is left to right. You only have the associativity of right, left for the unary operator. So the bitwise operator follow toward the bottom or left to right. Conditional ternary operator left, right to left. Assignment operator are always at the bottom. That's always evaluate last. And then if they are equals, other ones on there you evaluate right to left. And then comma is also referred to as an operator. That's left to right. Another concept through precedence and associativity that we are not going to really address with these other examples, we are going to end up using the parentheses all the time. And that's what you want to do. But again, if you want to fully understand the language, you want to understand the concept, that's why I tell it to you. Hello and welcome. We got another challenge for you. So we talked about operator in pretty good detail. Now I want you to make sure you understand these by giving you a challenge, trying to use some of these concepts that we have learned about. So I want you to write a program and I want you to create a C program that basically does some conversion, converting number of minutes to days and years. Now this program does not necessarily seem that useful. You may never know why you had ever do that. It will force you to use some of the operators, mainly the arithmetic operator, and get you acquainted with those. So that's why I'm giving you this challenge. This is very simple program. It should ask the user to enter the number of minutes via the terminal. So this is also your first challenge. Whenever you are going to use the scanf function, I want you to actually ask the user to enter number of minutes. They are going to enter the number of minutes, and then you are going to provide an output the equivalent of those minutes in years and days. Now it gets tricky because these are all about to be doubles. So the conversions are going to actually, or the results are going to be decimal numbers whenever you have floating point numbers, because a lot of times you might enter 50 minutes. Well, how is 50 minutes equivalent in years and days? Well, it's 0.0000 or something, because years and days are much larger than minutes. So it's not a necessarily useful program. It's not necessarily a complex program. You are going to just do some calculation, but again, it's going to get you familiar with the basics. Sorry. Basics of operator, mainly arithmetic operators, and also allow you to perform a calculation. And then the other good thing here to learn is the scanf. You are going to need to create some variable to store. They all should be type double, because this is going to be very precise program. minutes can actually be an integer if you want, but the rest should really be doubles. You see here that minute needs to be available. That's what you are doing to do your scanf function that you read in from the keyboard. Minutes and year, this is necessary because this is how you are going to do your conversion. So you need the minutes and year. And the reason that you can use the minutes and in the year to actually calculate the number of years, because the user is just going to enter the minutes. You need to know how many minutes are in a year to display the number of years. So I would expect you to have a variable called minutes, and you that would be something like the one number of minutes in an hour, which is 60, times the number of hours in a day, which is 24, times the number of days in a year, which is 365. If you do 60 times 24 times 365, that's going to give you the minutes in this year. You can then use the minutes and year and divide it by the minutes entered by the user, and that will give you the number of years. So it's a little more complicated than you think. Again, you are going to need to figure out this calculation. I'm not going to give you any hints on the exact calculation. I probably gave you too much already, but what I expect to see is output is the conversion. So you need to perform a calculation using all the arithmetic operators. You have to figure out the conversions. I'm going to implement this, but I would expect something very similar, creating some variables using the actual scanf function to read and input into a variable and then assigning those variables some calculations. I think you will need to use the division multiplication operator as well as the modulus operator. Okay, I'm not giving the solution of this channel challenge. Okay, you have to solve this, and I will check. Okay. Hello, I want to provide another challenge for you this operator section. Mainly, I want to demonstrate the use of the size of operator. So let's start in describing the requirements. In this challenge, I want you to create a C program that displays the byte sizes of basic data types supported in C. So the reason this challenge is kind of cool is because I keep mentioning, but maybe it has not stuck in your head, in your memory, that depending on the actual system you are running on, whether different operating system or different architecture hardware wise, you may have different memory size for the various data types. Int maybe 4, int maybe 8, doubles maybe 8 or 16 or whatever the case may be. And it's very important to understand that if you are start hard coding numbers, it's going to cause problems in your program. So you want to use the size of operator. Now you don't necessarily have to worry if your program is running on a certain system. It's always going to work the same. So this challenge demonstrates that it forces a lot more when we talk about pointers. But this would get you little challenge that will get your hands a little dirty with this operator and also get you more familiar with some format specifier related to this operator. So again, depending on the system you are running, the output might be different for this program. But you are to write a program that displays some basic data type size. It's pretty simple. Don't take you that long. But what I want you to do is use the printf function to display the byte size of the following types: int, char, long, double, and the usefulness of this program will be run on multiple actual computers to see the differences. But when you print out this data, you can use the %g format. This is supported in C99. So you should be good, but this format specifier will help format its size and print it out correctly. Other than that, this function or this program is really just going to use the size of operator and demonstrate how sizes vary from memory for different data types. Again, the key will be to test this on more than one computer to see the difference. But this program should not take you that long. You don't even actually have to create variables. If you are clever, you can just use the printf statement themselves and see. This is more for your knowledge on the size of operator. In addition to these challenges, definitely two more challenges on using the operator. For converting different types, there can be all sort of conversion. I mentioned the Fahrenheit to Celsius, but you could came up with the conversion for converting any type of data set, or just go into your math book and look for different equations and try writing programs for that will also help you get familiar with some of the different operators and see and how they are supporting, how they are used. But good luck on this one again.